Alright, so let's take a look at this problem number 5. Again, we're going to use this chart that Mrs. Chambers has made for us. Number our equations, and I suggest that you look at equation 2 and pick the variable to eliminate that has a 1 or negative 1. So I'm going to eliminate z. So if we use equations 1 and 2, this 2z I need down here to be a negative 2z to cancel those out. So I'm going to multiply everything in equation 2 by negative 2. So let's write equation 1 down. Let's write equation 2, but we have to multiply it by negative 2. And the whole goal, the reason for multiplying by negative 2 is so the z's will be equal and opposite and that they'll cancel out. So that's what happens here. Alright, so we have 7x plus 7y is negative 7. And some people might recognize that all of those are divisible by 7. And if you divide everything by 7, the numbers will be smaller and easier to manage. But we'll just leave it like that. We still need to eliminate z. And now we're using equations 2 and 3. So we have a positive 3z here. So we need a negative 3z here. And I'm going to multiply everything in this second equation by negative 3. So I have 9x plus 6y minus 3z is equal to negative 9. If I just write down equation 3, the z's are equal and opposite, so they're going to be eliminated. Alright, so we have 11x plus 5y is equal to negative 17. Now, it's going to be to your advantage if you recognize that all of these are divisible by 7, because right now the 7 and 11 and the 7 and 5, I'd have to multiply both equations by the opposite coefficient and make one of them negative. It will be easier for you if you can recognize here. I'm going to shrink this up a little bit. If we divide every term by 7, 7 divided by 7, negative 7. So we get 1x plus 1y is equal to negative 1. So now we can eliminate x or y. It doesn't matter because we have coefficients of 1 here. So let's eliminate the x. So since this is 1x, I need it to be a negative 11x. So I'm going to multiply everything here by negative 11. So when I do that, I get negative 11x minus 11y is equal to positive 11. When I copy down the equation from the second column, I have 11x plus 5y is equal. The x's are eliminated, which is what I wanted. Negative 11y plus 5y is negative 6y. 11 minus 17 is a negative 6. And when you multiply by 1, you get the identical thing back. We have that y is equal to 1. So we can use either equation from column 1 or column 2 to plug in y equals 1. In fact, I can use this reduced equation, and that's what I'm going to do. I have 1x plus 1y is equal to negative 1. But I didn't write the y down because I know y to be 1. So what this says is x plus 1 is equal to negative 1. If we subtract 1 from each side, we see that x is equal to negative 2. I'm going to use equation 2 now to figure out what z is. Let's write down equation 2. We've got negative 3x, but we found x to be negative 2. We've got minus 2y, but we found y to be a positive 1. We've got plus z, and that arithmetic, the claim is that it should equal 3. So if we replace x with negative 2 and y with 1, we've got 6 minus 2 plus z is equal to 3. 4 plus z is equal to 3. Subtract 4, and I have that z is equal to negative 1. So we have found our solution. We found x to be negative 2, y to be positive 1, and we just found z to be negative 1. So I hope that helps.